All right, before we get into the messaging services, I wanted to present a little bit more detail on the new type of way of communication, which is publish subscribe. We've already looked at request response as part of the client server model. A client sends a request and waits for a response. So request response is definitely a way that microservices will talk to each other, but publish subscribe is definitely a newer, more efficient way. So here are some key characteristics of the pub sub model. So a publisher sends a message to a topic. So rather than sending it directly to whoever's requesting, right, the information, it's going to send it to a topic, and that topic can distribute the message to a bunch of different subscribers. So it's not one to one like request response; it's one to many. Another key thing is that the publisher doesn't have to wait for a response in order to continue sending messages. So in request response, you send one message at a time. You wait until you get your response, right? Before you continue. In the case of the publisher, it's continue to pump out messages and doesn't really have to wait for something to come back in return. It's kind of one way. This also makes it asynchronous because it's up to the subscriber, right, when they actually receive the message. Asynchronous means like at a later time, right? It's not working in unison in terms of time. So request response is typically synchronous in kind of the sense that we're talking about waiting for a response. So pub sub, ideal for event-driven architecture, real-time data, notifications, etc. In the request response model, like I said, it's one-to-one. One client makes a request to one server at a time, at least. Here are some key characteristics of the request response model. So the client depends on the server response. It's synchronous because the client has to wait. This is still useful, right? You got your database queries, function calls, REST APIs. It is definitely one way of communicating between microservices, but PubSub has some advantages. You can send one message to one topic, and that topic will kind of distribute it amongst many subscribers. A service in Amazon that actually handles pub sub messaging is the Amazon Simple Notification Service. It enables applications, microservices, and distributed systems to send notifications to multiple subscribers in a scalable and decoupled way. We'll talk about that decoupled a little bit more. So this is similar to the coffee shop. The cashier provides coffee orders to the barista who makes the drinks. They are decoupled. We'll explain that in a sec. In Amazon SNS, subscribers can be web servers, email addresses, or even other AWS instances like Lambda servers, or I should say serverless, right? And there's also several other options. So suppose a coffee shop has a single newsletter that includes updates from all areas of its business. So bringing back that coffee shop analogy. So there's topics such as coupons, coffee trivia, and new products. So these topics are grouped together because it's the coffee newsletter, right? So whenever the newsletter goes out, everyone's going to get updates on all three topics. But after a while, right, some of the customers are probably going to get a little bit annoyed, right? They don't want to get emails, for example, on all three topics. Maybe they're just interested in coupons, maybe just trivia, or maybe a combination, right? Maybe they want trivia and new products, or just maybe new products and coupons would make a lot of sense. So yeah, this is Amazon Simple Notification Service, right? You're sending over these topics, all these topics over to all of these subscribers. Now, instead of having a single newsletter, right, the natural thing would be to divide the messages by topics. So each newsletter is now devoted to specific topics. So this is a better way of doing things. We have 3 newsletters now: coupons, trivia, and new products. So subscribers will now receive updates only for the topics that they subscribe to. So you can subscribe to one topic or multiple. So maybe a customer, again, subscribes only to the coupons topic. So they're only going to get coupons information. And the second subscriber subscribes to coupons and new products. So they're going to get on 2 different topics. So this is what that would look like, right? For example, trivia, new products going to customer 3. And then trivia just going to customer 2. They're only getting trivia, I should say, and then customer 1 just getting coupons. So this is how notifications system or service works with SNS. is you can publish to a topic, and then the topic will send to whatever services subscribe, right? Those services aren't going to be customers, they're going to be applications. They could be users, right? Depending on how your application works. I can say users, right? Managing other services as well. So Amazon Simple Queue service. So this is a little bit different way of handling things, right? Of decoupling things. So it enables the decoupling and scaling of microservices, distributed systems, and serverless applications. So tying this back into the barista, right? We're going to see how when you don't have to send things in a particular like order synchronously, you can actually handle things more efficiently. So with SQS, you can send, store, and receive messages between software components. The big one is store, right? Sometimes your services aren't ready to handle 1,000 different messages at once, right? Maybe it can only handle one at a time, but maybe your other service that's actually producing those messages, right, is ready to send all 1,000 messages. Well, the best way to handle this is through a queue. And we're going to look at the coffee shop example to kind of explain how that works. So in SQS, an application sends messages into a queue. A user or service retrieves a message from the queue, processes it, and once the message has been processed, right, we don't need it anymore. We'll delete it. So let's bring this back into the coffee shop example. So suppose that the coffee shop has an ordering process in which a cashier takes orders and the barista makes the orders. So we're going to envision a system without queues. So we actually do use queues all over our lives. So think of the cashier and the barista as two separate components of an application, right? Two different apps. So first, the cashier takes an order and writes it down on a piece of paper. Next, the cashier delivers the paper to the barista. Finally, the barista makes the drink and gives it to the customer. When the next order comes in, the process repeats. This process runs smoothly as long as both the cashier and the barista are coordinated. But what happens if the cashier took an order and went to deliver it to the barista, but the barista was busy with another order? So like they're taking these orders one at a time, right, as they get it. The cashier would have to wait until the barista is ready to accept the order. So let's say they don't have any paper, right, to write things down. They can just say one order at a time. This would cause delays, obviously. So it would require customers to wait longer to receive their orders. And if the coffee shop becomes super popular, right, if they get a lot of customers, the order line is going to get really slow, right, doing this one at a time system. So, of course, the owners are going to notice, right, inefficient. Maybe there's a better way, and of course there's the queue. So without a queue, right, customer orders, cashier gets the order, and then one at a time delivering the order to the barista, and then it goes to the cashier. So it's a very, very like simple loop, but with that loop comes inefficiencies, right? Now, if we can actually store those orders somewhere, like a queue, then things could get a lot more efficient. So recall that the cashier and the barista are two separate components of an app. A message queue service such as SQS can help decouple the applications, right? So that they're not so tightly stuck together based on how they communicate with each other. So if we use a queue to handle the customer orders, things will get a lot more efficient. So the first step would stay the same, right? Customer places an order with the cashier, but instead of sending it directly to the barista, we're going to put it on an order board. So here the order board would be SQS. The queue system is the order board handling the messages. In this case, the messages would be orders. And of course, right, if this is a really big coffee shop, they might actually be using AWS, right, to handle their POS system. So although we're using this as an analogy, right, this can definitely be an example of a real cloud computing application. So the order board is the SQS, right? And it's a buffer between the cashier and barista. So even if the barista is busy with another order or they're on break or whatever, customers can continue to place orders and cashiers can continue to handle them. They're just going to put them on that order board, which is the queue. So the barista, whenever they're ready, they're going to come back, check the queue, and retrieve the order. And that means they're going to be able to prepare the drink, give it to the customer, maybe prepare multiple drinks, who knows, right? And once they're done completing the order, they're going to remove it from the queue so that the queue is going to continue, right, to be popular with new orders. Maybe they're not handling the orders immediately after they're put on the queue, right? Maybe there's some time in between. That would be asynchronous, right? The time in between putting the order in the queue and actually handling the order. That's asynchronous messaging. So in this example, the cashier's the producer of the message. The order board is the SQS queue. The barista is the consumer of the message, and the whole system is asynchronous because the cashier and barista can work independently and don't have to wait on each other to continue their work. So here's what that would look like, right? We're just adding one thing to the loop, and it's this queue. And this arrow really should be like back and forth, right? Because the barista is going to be coming back and forth to the queue. So yeah, this just like additional step, this additional tool is going to make you way more efficient. And yeah, that's how the Amazon simple queue service works. It's doing the same thing as what most restaurants do, right? With pretty much any types of messages. And rather than the workers being, your barista and cashier, it would be two different applications. It could be a user as well, right? A user and an application. Basically, whoever's trying to send those messages between your computing resources. And yeah, that's it for our messaging and queue system. Very, very tightly related to microservices, right? Because if you're going to have these different components that work independently from each other, you're going to have a good system of them talking to each other, just like the cashier barista example.